Hello and welcome to another JDConf session. Thank you so much for joining me. My name is Keto Man, and I will be talking today about Services Reloaded, how you can increase your throughput with Project Loom virtual threads. I'll tell you a little bit about myself. I can go to the next slide now. Okay. I'm the principal consultant at Virtua, where I do architecture, mentoring, development, and training using a variety of technologies, of course, with the core focus being Java, Java microservices, Jakarta EE, Spring Boot, microprofile, Quarkus, etc. But also with front-end development as well, using web components, Angular, mobile web, React, Vue, etc. And we are the official U.S. partner of PrimeTech, which builds open source UI component suites for Angular, Vue, JSF, and React. And we're also working on a site called SpeakerTracks, which is for frequent speakers. So if you are a frequent speaker and you'd like a tool to help you keep track of things, you should check it out, speakertracks.com. I'm also the co-host of the Stacked podcast, which is a podcast that I do every few months or so, every 1 or 2 months. We try to do 1 month, but it never really seems to happen that way. But it's me and a couple other guys, and we talk about front-end development, back-end development, and just software development in general. And usually we try to have a guest on usually just about every episode as well. And one of my co-hosts there is Daniel Inahosa. The other one is Josh Juno. And also a guy named Ian Lavitz. So we have a great time in there. So if you like podcasts, I encourage you to check it out. I'm also a Java champion, and I've been involved with several different Java specifications over the year through the Java community process. I'm also the project lead for the Eclipse documentation for Jakarta EE, etc., etc. So that's sort of my story. And usually at this point in the presentation, I usually ask the audience what their background is in relation to the topic. So since there is no audience live right now, I would like to know, let me rephrase. What I'm going to do is tell you sort of my archetype for this particular talk, so you can sort of see who it's tailored towards. So basically, I'm assuming or hoping that you are, number one, a Java developer, that you haven't worked with virtual threads that much, or you're curious about them, and that you have some applications in production or that you're working on where you think you could benefit from virtual threads, but you're not really sure how or anything like that. And you probably work with some web framework like Spring Boot or Quarkus or Jakarta E server or some sort of framework that makes it easier for you to build applications. So hopefully that's you. If not, you still may find it interesting because I do go through some of the historical context with virtual threads and sort of how they work. Okay, so let's start with a blast from the past. So we're going to go back to the 1990s. As my daughter would call these, as my daughter would say, these are the olden days. So back in 1997, we had JDK 1.1, and also we had 1.2 a couple of years later. And then in those versions of the JDK, we have a feature called green threads. And green threads were the only threading model available during that time. And I actually remember being very excited about this. So I was like, wow, what you could do was actually have multiple threads that you create, even though you could only run one thread at a time. And remember back then, we had fewer cores, right? We had only 2 or 4 cores if we're lucky. So we didn't have a lot of threads to work with. So virtual threads, green threads gave us the ability to sort of, act like we had more threads than we did, which gave us some performance gains. However, by 2000, those gains were sort of over, and they realized that, they should really just go back to, go to a more platform thread dependent model. If you're curious to learn more about green threads, I encourage you to check out this Wikipedia entry. There's a lot of great stuff there, a lot of history. But beyond 2000, we've had what we call platform threads. So between 2020, 2023, so for the last 23 years, in the Java platform, we've had basically a one-to-one mapping between a Java thread and a platform thread, which is basically just an operating system thread. Okay, so you create a new thread in Java, it creates a new thread at the operating system level. Very straightforward. And this has worked out well, especially in the beginning. But there is a drawback, and that is what we call blocking. So if you're not familiar with American football, either because you are an American and don't watch it, or you're not from the US and don't watch it, you can take a look at this picture here. So on the right-hand side here, we have the defense. I'm sorry, the defense. It's been a long day. And the defense is trying to get to the guy with the ball. That's kind of their job, get the guy with the ball. And the offensive line are these guys here. And they are blocking the guys on the defense and trying to keep them from getting to the guy with the ball. So you can think of this as an analogy for blocking for threads, because essentially each one of these defensive backs is a thread trying to complete its process, which is getting the guy with the ball, but they're being blocked. Okay, and most of them will not make it, actually. So it's hopefully a little bit of a worst case scenario for threads, but that's basically the deal. So when we have one platform thread per Java thread, if the platform thread, or if the Java thread blocks, the platform thread blocks, and that means is that there's less resources available to do the actual work, right? And this was fine for a long time. Apache Web Server was built this way. Apache wasn't in Java, but it's the same concept. It's still not in Java. But there's one thread per request, and if that thread blocks, then it blocks. On the Java side, we have the Servlet API, which has been the standard way for doing responding to web requests for a long time. And that has servlet containers like Tomcat and Jetty, and there's been many others over the years. And they have the same model as well. They would block if a thread came in and had to work with a resource like the disk or the network or something like that. Jetty, of course, has changed a lot, and it has not a lot of non-blocking features at this point. And we'll see the Servlet API has evolved as well. But that's basically the deal. So that was great, and that worked for a while, but as time went on, machines got more powerful, we got more CPU cores, more threads that we could execute simultaneously, and we also had the internet getting a lot bigger, right? So, 97, internet not so big, 2004, internet's grown a lot by then. We've actually post-dot-com bubble burst, So at this point, we ended up with Nginx, which uses an event-oriented mechanism for asynchronous processing. And it really came about in order to deal with one of the major limitations in Apache. Apache Web Server could max out at 10,000 concurrent requests, which seems like a lot. But Nginx took it further. They could do a lot more than that by using an event-based asynchronous approach. So they basically paved the way for us moving forward with handling requests asynchronously. Around the same time, you had Netty, which is Java-based, and the same idea, uses an event loop. Node came out in 2009, a few years later. Same idea, handles events, non-blocking. Akka 2010 handles things has its own metaphors with actors and everything, but the same idea, and that works in Java and Scala. And Vertex came out in 2011, and that actually is a little higher level. It's built on top of Netty, but it has also the ability to build entire services as well. So, throughout the 2000s, we saw the proliferation of web engines that were able to handle things asynchronously. All of these features made their way into the standard Java APIs in the early 2010s. So Server 3.1 added support for asynchronous requests using the async context. And in Server 3.1, which came out in Java EE8, which later became Jakarta EE9, in that version, NIO support was added. JAX RS, which is now called Jakarta REST 2.0, added support for the async response method. And in Java EE8, which is now Jakarta EE9, that has you have the ability to return a completion stage, which is a primitive part of the Java API for handling asynchronous requests. So all of these asynchronous features made their ways into sort of the core base APIs. And then around the same time, we had the Reactive Manifesto. And this is really sort of the formalization of a lot of the things which have been bubbling previously in the reactive space. And the idea was really to make things more resilient and responsive and do things in a message-oriented manner. So in order to implement all of this, we had a whole bunch of new APIs. So ReactiveX, which was formerly the Microsoft Reactive Extensions, started with the .NET version in 2011, RxJS, RxJava, and others as well for different platforms. And that gave us some standard mechanisms for working with reactive programming, some standard APIs, standard concepts. Also in 2013, we had Spring Reactor, which is another set of APIs for working with reactive techniques. We had reactive streams. Those actually made their way into Java 9 using the Flow interface in 2017. Small Y Mutiny, which is used by Quarkus in the Red Hat world, came out in 2021 as well. So that's sort of where the APIs were. But usually when you build an application, you use an actual framework, and then you may use these APIs with that framework. So on the service framework side of things, Spring Boot you can use with Webflux and to use your reactive APIs. Quarkus, you can use Mutiny. Vertex has integrated support as well, and Micronaut as well. So all of these let you build things using reactive APIs, okay, out of the box. But if you look at how you build those applications, it's actually sort of a different world, because on the left-hand side here, we have the reactive stack for Spring, right? So you use the Spring Webflux, right, which is the non-blocking web framework, right? You can use that with Netty Servlet 3.1, which we know now actually supports asynchronous requests. We also have to use reactive stream adapters, Spring Security Reactive, Spring Webflux, Spring Data Reactive repositories. So basically, you have different APIs for every single piece throughout the stack. Whereas with the Servlet stack, you can use your normal one request per thread model that you're used to, but you have the problem with the synchronous blocking, okay, if on any IO requests, okay? So we get the benefit with reactive of increased scalability, increased throughput, right? But the drawback of the programming model, essentially. And it turns out there's a little bit more to the programming model issues than just the fact that they're different APIs, right? They're actually a little hard to work with. So the code is pretty hard to read. This is an example from the Speaker Tracks project, which I was talking to you about. We're actually using Hibernate Reactive and Quarkus with Mutiny. And you can see, it's very functional, uses a lot of stream APIs, right? But it's also kind of a lot of stuff going on here. And this is just one method for persisting an object, right? Persisting a speaker session, actually. And there's a whole bunch of parameters here, right? And of course, this is a generic method, so it's going to end up doing a lot more stuff. But you know, there's a lot of calls in here, and a lot of chaining and calling and replace with and all that kind of fun stuff. So it's readable, but it's not the most readable code. And obviously, this is just one very small portion. But you imagine a large application. You have lots of code like this. A new person joins that hasn't really worked with a lot of reactive programming. It's difficult to get to grasp around. Doable, but not the quickest thing to do. So the other issue is that stack traces are kind of a pain. So this is a stack trace from speaker tracks, and you see we have a validation exception at the top. Requested entity does not exist. Please specify another ID. Okay, that sounds fine. That's normal. But if we try to find out where this problem is caused, now the first part here, this is just one of our utility methods. It's a GraphQL application, but it doesn't really matter. The point is that this exception is being created from this utility method, right? But then if we look for where it actually got called before our code, it's not really obvious because all I'm seeing here is a whole bunch of mutiny code, and then some completable features, part of Java util, and some operators, and a whole bunch of other, oh my goodness, there's vertex, there's netty, vertex, netty, and then the beginning of the stack. So I have no idea where my code was called, or what actually caused this problem. Now there are, with some reactive frameworks, there is the ability to sort of provide some more guides and guidance and generate stack traces which are more meaningful, but it's still not going to be as meaningful as a normal Java stack trace. Okay. So if we look at sort of that trajectory, right, of we started out with blocking imperative programming using blocking APIs, which was easy to program but not the most scalable, or didn't have the best throughput depending on what your situation is. And then we have all the reactive stuff, which is really flexible and lets you build stuff that has high throughput. You never really have to block on anything, right? But the APIs that you work with are pretty difficult to work with, right? You have harder to work with APIs, and you have to use those special APIs throughout your entire stack, right? So programming model, not really the best. Debugging is kind of a pain in the butt, okay? So with JDK 21, which came out in 2023, and this is the most recent LTS release if you're afraid of newer versions of the JDK, that is the goal of this project is to sort of change that trajectory. Okay. So the OpenJDK works through different projects that create different Java enhancement proposals, and which are called JEPs, and those make it into the platform, one by one, essentially. So a particular project may have different JEPs that get released in different versions of the JDK. So Project Loom, the official name is Fibers, Continuations, and Tail Calls for the JVM. So Fiber is it's a synonym for virtual thread. It's just a lightweight thread. Continuation is the ability to take some code that's executing and then pause it and then continue it later. And tail call optimization is really about making sure that recursive methods are optimized more efficiently. So we've gotten to the first two things. Fibers are basically just another term for virtual threads, and the JVM does use continuations internally to make all this stuff happen. So in terms of JEPs, we have 449, which is virtual threads, final in JDK 21. And there's a couple related ones. Structured concurrency, which is basically the ability to treat a group of related tasks running in different threads as a single unit of work. And this lets you do things like error handling, cancellation, improved readability, etc. So it allows you to basically structure your work across different threads. Then there's also another one called scoped variables. And scoped variables basically lets you have immutable data that you can share between a thread and its child threads. And the main idea there is that you can do the same thing that we do currently with thread pools, using thread local variables, but in a way which works better with virtual threads. We'll talk a little bit more about that. So those are both as of JDK 24, which just came out in March of 2025. Those are in fourth preview, and so I would expect those to be final pretty soon. And another thing that's important to remember is that with preview features, they are like, production features, but they may change, and hence the preview label. So Fruit of Loom, Loom started in 2017. First preview came out in 2019. Final version of Virtual Threads came out in 2023 with JDK 21. And this has end-to-end scheduling. So whereas normal Java threads have one-to-one scheduling, one Java thread per one platform thread, with virtual threads we have M number of virtual threads mapping to N number of platform threads. And this makes things very different from the way things were before. So one of the key things that's different is that the JDK is doing the scheduling. So with platform threads, the OS does the scheduling because that's its job, right? With virtual threads, the JDK actually is doing the scheduling of the virtual threads. And so you can have X number of virtual threads. There's really no specific limit to how many virtual threads you can have. Although obviously, if you run out of resources and everything, your app will still die. But it's not like there's capped at some particular number or anything. And of course, OS threads depends on the platform itself, right? But basically the way it works is when you have a virtual thread, it's basically parked until it's actually attached to a platform thread. And a platform thread that has a virtual thread is what we call a carrier thread. So a platform thread carries a virtual thread. So these three here are called carrier threads, and these are just platform threads that don't have a virtual thread yet. Okay, so everything goes fine. We basically will take a virtual thread, hand it to a platform thread whenever it blocks. We pull it away from the platform thread, park it, and give the platform thread a new one to work with. Okay. The only issue is that occasionally we'll have problems where a platform thread will get pinned, and then as a result, think of it this way. Let me take a step back. The virtual thread will block, and that pins the platform thread. Okay, so in this scenario, this particular thread, the virtual thread blocked on some I/O or something, but because it's waiting, the platform thread is just stuck. It's like, hey, I can't go anywhere. It's sort of like when you're having a conversation with somebody, and you were trying to go somewhere, and they talk to you, and they just keep on talking to you, but you need to go, but you're blocked. Sort of like that. It's like you're stuck with the platform thread. So that is something to keep in mind, and this is one of the drawbacks with virtual threads. And this can happen whenever you use a synchronized block, because synchronized blocks are tied to the platform thread, not the virtual thread. And the way to get around this is to update your code to use the reentrant lock instead, which is part of the Java concurrency utilities. The other scenario where this happens are native calls, right? Because native calls, you kind of have to wait to do for the operation to succeed. Now, hopefully your native call is fast, but you do have to wait on that. So one of the things you can do is in situations where you don't want to pin a thread for native calls or for long-running actions, which is something we'll talk about a little bit later, you could create a normal thread pool for that kind of work. But the synchronized block is definitely an issue. One of the things you can do is that you can use this command line parameter, trace pin threads, to log whenever there's a pin thread that occurs in your application. This is a good thing to do, sort of test out your application and see how it's going. Like, are there pin threads going on when I run my application and do load test, for example? So a few things that you need to keep in mind when you're working with virtual threads. You don't need to pull them. You don't need to pull them because usually a pull is something you reserve for expensive resources, right? Things which are expensive to create, so you don't want to keep on creating them. So you pull them so that you just have one available whenever you need it. With virtual threads, you can create as many as you want, and the overhead for creation is very tiny, so they're very cheap to create. So you may as well not worry about pooling, and actually they recommend against pooling. It's not really necessary. Um, and you also want to avoid long-running actions. This is what I just mentioned. So the other thing that can happen is that if you have something which is computationally expensive, not blocking on I/O, but taking up a long time to do its work, right? That also can monopolize the thread, sort of like pinning. And in that scenario, if you have a lot of those threads, you're going to end up sort of, they'll all be blocking and you'll be creating lots more virtual threads. So in that scenario, again, it might make sense to have a pool of regular threads that you work with for those workloads. We talked about thread local variables briefly. Thread local variables are tied to the actual thread, either the virtual thread or the real thread, depending which one you're using. But often they're used to cache objects, right? So if you're trying to cache things that are going to be used by the same thread, you put stuff in a thread local. Usually that works fine, but in a virtual thread environment, it doesn't work as well because we're creating many more threads, right? So whereas before, your pool, you weren't creating all that many threads. Now you could be creating thousands. You can't use the same pooling technique. So the alternative to this is to use scoped values, which again is in preview. And it's in preview in JDK 24, but also in older ones like 23 and 22, etc. They just have different preview versions. So the alternative is to use that. And with scoped values, you can do the same sort of thing, but in a way that works well with virtual threads. So if the synchronized keyword thing is bothering you, fortunately, JDK 24, which came out in March of 2025, actually solves this problem. So it actually fixes the JDK in a way so that virtual threads do not cause a problem with synchronized blocks. So you can have all the synchronized blocks you want, it'll work fine. And this JDK trace pin threads option will basically have no effect. So you're good to go with that. And again, that's only with JDK 24. And just a reminder that even if the release is not a LTS release, it's still a production-ready release that you can use. Every release of Java that's like an official release is production-ready, ready to use. So just want to point that out. JDK 24 also has the Java flight recorder events monitoring. So you can monitor all of these sort of different metrics or different events, I should say, for virtual threads, even though you don't have the logging capability. So you can find out when threads start and end, when they're pinned, when the scheduler is trying to submit one to a virtual thread, to a platform thread, or is trying to move one from a platform thread. All those things you can track, and you can listen for those with any tool that supports Java Flight Recorder events. And Java Flight Recorder lets you do monitoring as your application is running. Okay, so these are the virtual thread APIs, which are very straightforward, right? You don't see anything different from the normal Java thread API here. The only difference is this method, right? New virtual thread per task executor, but the executor has the same API. So basically, you just use a different executor, and then you're good to go. Very simple. You can, of course, create things manually using, there's a new virtual method that you can use, and there's also a new start virtual thread method. And then for any thread instance, or for basically while you're running, you can check to see if you're in a virtual thread or not. Okay, so one of the things I do want to point out is that, I'm trying to see how much time I actually have left, which is basically none. Okay. So I'll go through this quickly, but it's important to understand that all this wonderful stuff with Loom didn't happen overnight. It happened over many years. So I said the project started in 2017, and throughout between 2017 and now, all these internals have been reworked to support virtual threads. You know, the thread API, all the concurrency utilities, NIO utilities. There have been debugging tools which have been updated, other JEPs which have been updated. There's been several other JEPs which have been sort of prerequisites for virtual threads. So 353, re-implement the legacy socket API, internet address resolution SPI, etc., etc. So there's been a lot of stuff there to sort of lay the groundwork for virtual threads. So this is all great, Keto, but how can I use this stuff? I never use the thread API. Like if you don't use an executor or the thread API directly, you can still take advantage of this stuff because it's used by, because it's used by all of the frameworks that you do use, right? So we talked about the APIs themselves at the thread level, which are pretty straightforward. So then when you look at your web server like Tomcat, it has support now in 10.1 or higher using a different virtual thread executor. Jetty as well has support, either via a little bit of Java code if you're using the embedded mode, or via the command line. It's very easy to use. And also, well, I'll talk about some of these other ones. So these other ones don't necessarily have the same support. So Netty, not so much. Undertow, not so much. But there is support among the core sort of key frameworks or key web servers in the Java space, like Tomcat and Jetty, etc. So that's sort of the web server level. Now, at your actual application framework, your microservice framework, or your application framework level, there needs to be support as well. Fortunately, there's pretty good support at that level too. So Quarkus has good support. It's almost as good as Reactive. They recommend using Quarkus REST, so you can check out this virtual thread guides for more info on that. This is what it looks like. It just uses this run on virtual thread call. Very straightforward. They have more of an opt-in style approach, which is nice. Find some examples on GitHub. And Helidon, which is Oracle's microservice framework, has support as well. They actually rewrote their web engine, which was using Netty. They wrote a new one called Nema from the ground up using virtual threads, and they've been very happy with the results. So they have full support there. Micronaut is also from Oracle. They also have full support. And for Spring Boot, if you're using an older version of Spring Boot, like Spring Boot 3.2 or I'm sorry, 3.1.x or earlier, you can add support by using the task executor. So basically, by overriding the executor that Spring uses. Okay, and this is an example of what you do if you're using Tomcat for your web server, but you could be using something else. So this works. This may not have the best performance, but if you really want to try things out on an older version of Spring Boot, you can try this out. However, official support for Spring Boot has been added in Spring Boot 3.0 and higher. So for there, you just have to set a parameter to turn on virtual threads. You also need this so that Spring stays alive while it's running all these virtual threads, because they're daemon threads. You can find some details here with the Spring Boot release notes. So on the Jakarta EE side, this is basically an implementation detail. Different servers may have a different thread pool that you can use, but it'll be a configurable option that's server specific. And of course, it's already supported in the main server containers like Tomcat and Jetty. However, if you are using Jakarta concurrency, which is basically using managed executors essentially for concurrent operations, there is support in JDK 11. I'm sorry, Jakarta 11, excuse me. So in Jakarta 11, which actually just came out, or is coming out, depends on how you're looking at it. Parts of it are coming out now, parts of it are already out. But with Jakarta E11, you can use it with managed concurrency as well. Okay, so I'll just mention some drawbacks really briefly. We talked about all the sort of drawbacks that are innate to using virtual threads, like pinning, monopolization, using local threads for caching. And so the important thing to remember is that even if your code handles those things, your third-party code may not. And that's really, really the issue with adoption of virtual threads. It's really much more about the third-party libraries they're using. And so you just need to basically spend some time and look at the key dependencies you have and see if you have a version that supports virtual threads, or if maybe there's no issues with virtual threads at all because of the way it was written initially. You'll have to find out. So just as a couple examples, Jackson added support in 2.16, but really it's more at the level of the framework that integrates it, so whether it's Quarkus or Spring or whatever. For those who don't know, Jackson is the most common way to work with JSON in Java. There are some other ways, but that's the most common one. OpenTelemetry had some issues with the JDK trace pin threads parameter for a while. That's been fixed. Database drivers, just take a look and see if your database driver supports virtual threads. Most of them mention it in the changelog. So, you know, Postgres did it in 2023, Oracle in 2022. This means you may need to upgrade those drivers to a more recent version. MongoDB did it in 2023. SQL Server did it in 2023 as well. And you will find some of them may not make it that public. So, for example, for SQL Server, I had to actually go to the GitHub and look at all the release notes to find out, you know, when they fixed issues. So sometimes you have to do a little bit of digging to find out. But take a look and see how well your dependencies are handled. MySQL as well, 2024. So if you want to learn a little bit more about those drawbacks, take a look at this Quarkus blog post. I think it's really well written. Just keep in mind that things have changed a little bit. I think it's about a couple years old, but it's still a good starting point. And also remember that this trace pin threads feature is a good idea. It's a good way, if you're not using JDK24, it's a good way to sort of test your code to see what the deal is and see if you have any issues popping up. In JDK24 plus, you can just listen to those Java flight recorder events. There's also a JUnit extension called Loom Unit, which you can use to detect pinning during tests. So you can check that out as well. And I think that is it for me. I have rushed through this as fast as I can. Hopefully you can still understand me. But anyways, thank you so much for your time. Thank you so much for coming, or at least watching, JDConf. It's been a pleasure being here. If you have questions, you want to chat about this stuff more, you can find me on the socials. You can get to them all from ketoman.com. And you can also find my website, my company site at virtua.tech. And also, if you want to learn more, here are some links. There's a virtual threads overview, some JEP links, etc., etc. So check those out. Hope you enjoy the other sessions, and thanks so much for your time.